Here's the solution for problem number 14 from exam 2, engineering 1301, fall 2018. Alright, so I know you guys freak out with op-amp circuits, but I'm trying to impress upon you that ideal op-amp circuits are really pretty straightforward, pretty easy to do. Alright, so I was a little surprised that I tried to throw some GIFs in for you, part A and part B. Remember, we had talked about in class there's certain assumptions you make with op-amps, and one of the ideal assumptions is that the input current onto either the plus terminal or the minus terminal is 0. So that was, that's deceptively easy, but you could just write down the current's equal to 0. Okay, in part B, what we know is that there's this virtual short assumption. Okay, so I'm asking for the voltage VA, and so I'll start at my reference. Here's 0 volts. I go up to here, that's 0.3 volts. And what we know is the voltage at the plus terminal and the voltage at the minus terminal are the same. That's the virtual short condition. That it's as if there were a wire connecting those. There's not really a wire, but that's the assumption that we make. So in that case, since this is 0.3 volts, then VA is 0.3 volts. Okay? And then in part C, what I had hoped you would recognize that this is that this is a non-inverting op-amp circuit. Okay, and so what that would mean is that the output voltage is going to be a certain formula, 1 plus the feedback resistor over R times Vn. Okay, and so if you knew that, and a lot of you did, that would be 1 plus 10K is the feedback resistor coming from here, and then R is 2K, and Vn is 0.3 volts, and so we get 6 times 0.3, which is 1.8 volts. Okay, let's say you didn't remember that. What would you do? Okay, well, what you do is you write a node equation at node VA. Alright, so let me change the colors here. You would have this current, but we know that current's 0, right? It's coming into the terminal of the op-amp, plus this current, plus this current. The sum of those currents is equal to 0. Alright, so you have 0 plus, alright, one would be VA minus 0 over 2K. The other would be VA minus, alright, so here's V out, right? So V out, slide the dot. This would be V out, VA minus V out divided by 10K equals 0. So this is an equation. You know VA is known, VA is 0.3. You can solve for V out. So you didn't need to recognize that this was a non-inverting op-amp circuit. You could have just written a simple node equation to get that answer. Alright, so that's the solution for problem number 14.